Hello, ladies and gentlemen. Welcome back. Now that have school back in session and everybody knows what's expected of them, I did have a couple of topic requests for videos because nobody could find it quickly in the playlist that I've already made. I'm pretty sure two of these videos I've already made, but having something specific doesn't hurt. All right, so graphing parabolas, let's get right down to it. Brass tacks. Here we go. This first topic is actually a rehash of something you guys learned back in chapter 1. If I can get this, there we go. What you're looking to be doing here is you need to remember the formula, let's see here, x plus or minus h squared plus or minus k. What we're doing here is you're taking care of moving left and right, and then up and down. So this here is inside my parentheses. Since it's inside my parentheses, it's going left and right. And since it's minus, that means it's going to be going right 4. And then this one is outside the parentheses, which means we're going to be going up and down. So specifically, since it's a minus, we're going to be going down 3. So if we go down 1, 2, 3, and then over 1, 2, 3, 4, there is the vertex of my parabola. From there, if you're lazy and you want to hack, there is something called the 1, 3, 5 rule, which means you're going to go up 1, up 3, up 5. So specifically, I want to go up 1 and then over, and then I want to go up 1, 2, 3, and then over. And again, I mirror it on the other side. And if I have the space, you can kind of tell I don't here because I'm right at the margin. But over here, I can go up 1, 2, 3, 4, 5, over 1. And then there's my parabola. And that's all you're doing for this topic. So this one, I'm going to go right 4 and then down 2. So right 4, down 2, up 1, over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, over 1, and then there's my parabola. Do I have enough for 5? 1, 2, 3, 4. No, I don't. Okay, next one. Graphing in inequality. So again, beep. What you want to be careful of is if it is a dotted line or if it is a solid line. And then obviously if you are graphing above, is if it's greater than, then you are shading above. And then if it is some version of less than, you are shading below. Computer, don't lag on me, I just started. There we go. Now, the thing here is that you always want to make sure the y is by itself because it's in quarantine. So like this y over here is perfectly where it's supposed to be. So we'll start with this one first. We have the minus 6, that is our y-intercept, so we start at negative 6. And then it's just anything special here? Nope, it's just a plain old x squared, so up 1 over 1, 1 over 1, up 1, 2, 3 over 1, over 1, and then if you really want to be ambitious, up 1, 2, 3, 4, 5, over 1, and then over 1. And then there's your parabola. Now this one will take a little bit more work because you can see the x squared is in the wrong spot. So I'm just going to add it, and then I'm going to add it. So that leaves me with y greater than or equal to x squared minus 4. Oh, I forgot the shading, silly Ms. Dubois. All right, so let's look over here. Go back over here. You can see that it's not an or equal to, which means this is supposed to be a dotted line. Silly Ms. Dubois. Thinking I know what I'm doing. And then finally, it's less than, so we're going to be shading below. That's what it should look like. That looks a little bit better. Good grief, Ms. Dubois. This one, our y-intercept is minus 4. And then again, the x squared, you can see there's no extra signs here to modify it. So up 1 over 1, and then up 1, 2, 3, 1, 2, 3 over 1, and then up 1, 2, 3, 4, 5. I've been lucky here in the sense that I have had the space to go up 5. The computer does not, the software does not, this is a solid line, the software does not need you to go up 5. You can only go, you can get away with going up 1 and up 3. And since this is greater than, we're shading above So that's what it's going to look like. Now, these particular problem, because it's problem type 1, this one is usually set up already for you. You'll have a y-intercept and basically maybe a little bit of algebra, but that's about it. Problem type 2 is when we get a little bit crazier, because look at that mess. The horror, what do we do? Come on. Here we're going to have to do a little bit more algebra, but it's the exact same skills that we were doing up here and up here. There's actually almost no change. The only thing now is that we have to go through the effort of finding the vertex, and you can tell we're going to be doing some manipulation of our 1-3-5 rule. So first things first, you can do this one of two ways. The way I have been teaching you guys exclusively in the video tutorials is you're going to be doing opposite b over 2a. So that's going to be negative 12 over 2 times 2, which is negative 12 over 4, which is negative 3. So my vertex here is going to be negative 3 comma something. Well, what's my something? I have to go through the effort of putting the negative 3 into the equation. So 2 times negative 3 squared plus 12 times negative 3 plus 19. So 3 squared is 9, 9 times 2 is 18, 12 times 3 is 36 plus 19, 18 and 19 is 20, 37, 37 minus 36, 1. There's our vertex. So negative 3, 1. There we go. And now, traditionally, our rule has always been 1, 3, and 5. Right. 1. Oh, there we go. Maybe don't go. Now what happens here, this 1-3-5 rule only works if there's nothing in front of the x squared. And you can kind of see here that we do, in fact, have something in front of the x squared. The horror, except not really. Because what's happening is, even though we're going up 1, up 3, up 5, here's the thing. That is now, every time we make that change, it's going to be times 2, times 2, times 2. So what's 1 times 2? We're going to go up 2. What's 2 times 3? We're going to go up 6. What is 5 times 2? We're going to go up 10. And I know for a fact that they're not going to give us enough space for 10. But we're going to go up 1, 2, over 1, over 1, and then up 6. Up 1, 2, 3, 4, 5, 6, over 1, and then over 1. And from there, this is a solid line, because you can see the or equal to. And then it is less than, so we're shading everything below. So, and again, this right here, that is a DSA strategy. Right now, I'm telling you that, because there are a couple of you who are going to be doing the DSA really soon. Next up, this one. So we're going to do opposite B over 2A. So opposite B is 12 over 2 times 2, which is going to be 12 over 4, which is 3. So our vertex here is going to be 3 comma something. Let's plug it in. So 2 times 3 squared minus 12 times 3, then plus 21. So that's going to be 3 squared is 9, 9 times 2 is 18, minus 36 plus 21. 18 and 21 is 30, 40. 40 minus 36, which is 4. So 3 comma 4. 3 comma 4 is our vertex. And then we're going to have our 1, 3, 5. What are we multiplying by? It's going to be 2 again. So times 2, times 2, times 2. So we're going to go up 2, up 6, up 10. So up 2. You can see Ms. Dubois did not give myself enough space. So what I'm going to do, I'm going to change that to negative 2. All right, so now we're going to go down 2, down 6, down 10, down 2, down 1, 2, 3, 4, 5, 6. There, now I have enough space. This one's going to be dotted. And then it is less than, so we're shading below. And that is how you're going to be doing some of your basic graphs for your inequalities for both 4. Zoom out, zoom out. Look at all the math we did. Hey, aren't those pretty? But that should give you some basic ideas. One of these graphs, no, it's not this one, but these skills that are in here pop up in the DSA, so I hope that helps you, and I will see you in the next one.